All right, we're going to start 3.4. This one's going to go pretty quickly, so look alive, okay? This is 3.4. This is going to be part 1, and our focus today is going to be what we call a composition of functions. Composition of functions. But before we get to the composition part, we're going to look at functions separately. So we've got some rules, and I'd like you to write these rules down, and then we'll work some examples. And just write them down, and then we'll talk. You don't like anything to deal with functions. Listen, functions are going to be in your life from now on. As long as you're a math kiddo, everywhere you go from now on is going to have functions.
Good thing I'm not.
It's like The Greatest Showman. From now on. All right, when you get these written down, look up, and then we'll talk about them.
I don't know what this means.
Yeah.
Yelling all over here.
What's G? G is another function.
What do you got?
2 functions. Are you ready?
No.
I'm just making stuff up here.
Oh, I didn't see that.
I'm going to let f of x be 2x plus 3. And g of x just be a different function. But I already used the letter f, so I got 25 more to choose from. I'm going to call this one g. Okay, it's not a whole new thing. It doesn't mean graph. It's another function. But I already used f as in f of x, so now this is g as a function of x. It's just a new name. Okay? Yeah, it's like if I have 2 kids named James and the other one's also named James, I'm going to call him Bob because I don't need 2 Jameses. Are you with me? You just call it a new name. Don't call them James 1 and James 2. That's confusing, right? So we give them different names. That's exactly what has happened here. We give the function a new name. Call it G.
How about we just not name kids James anymore?
Okay. All right, so given this information here, here's how it works. This on the far left side, this is a much less common notation. It's saying add up f and g, f plus g of x, and get a new function called f plus g of x. The way that breaks down is you just take your 2 functions, f of x, and add g of x. What is my function f of x? Say 2x plus 3. 2x plus 3. And I'm going to add g of x. What's g of x? Okay, this is going to give me a new function that is the sum of those functions. So 2x plus 3 plus x plus 1 makes 3x plus 4. Good, Zaylee. That's it. I can combine the 2 functions. Okay. Likewise, I could subtract them. Subtracting gets a little bit hairy because I'm subtracting an entire function, not just a term. So I'm careful to subtract the second function with parentheses so that I can do what to this negative sign? It needs to get distributed. So now I have 2x minus x, which makes x, and 3 minus 1, which makes. So the function f minus g of x is equal to x plus 2. That's all it means. Yeah? Okay, let's keep going. f times g of x is equal to f of x times g of x. Guess what? We know how to do that. Just kidding, we do. We can multiply two binomials. If they weren't binomials, you would still do the same thing. You're just going to distribute. We do first, which is going to be what? 2x squared. Outside, 2x times 1. Inside, 3 times x. Last, 3 times 1. So combining those, I get 2x squared plus, see? That is the function that results from multiplying f times g. Yeah? Everybody okay here? Okay, my last one says f over g of x, and I put a comma out here because there's a rule. I can do this as long as, when I'm dividing, I can divide as long as what? There's no 0 in the denominator. Can't divide by 0. That's what you meant, right? There's no 0 in the denominator. So we say this is the rule. F of x divided by g of x. Provided that g of x, the function in the bottom, never equals 0. So that's where we get some kind of restriction. Okay, so let's try it. We're going to do f of x over g of x. 2x plus 3 divided by x plus 1. Nothing to simplify here. That looks just fine, but we're going to have to state the restriction. This is the function provided that, what? What would 0 out the bottom?
Negative.
X is not negative 1. Good. Provided that x doesn't equal negative 1. The way you find that is you set the denominator equal to 0, solve for x, and then you know this is the domain restriction on that. The domain for this function goes from negative infinity to negative 1 and negative 1 to positive infinity. So we say as long as x does not equal negative 1, that function works. Questions on these rules? Questions on these rules, anybody? Okay, so all we're doing here is we're taking two functions and we're kind of manipulating them. Playing with two functions at once. Okay, so let's go on. This is going to be example 1. Negative infinity to negative 1, and then negative 1 to infinity. Sorry, got a little excited. I like this lesson. It's easy. Now are we good? Yeah? Marcus, do you also like this lesson?
I love this lesson.
He loves this lesson. Okay, cool. Example 1, f of x is going to be x minus 1. G of x is going to be x squared minus 1. It's just like Mason said, we shouldn't name both kids James. So we named one F and we named one G. It's fine. The instructions here say find f minus g of x. And I really, really, really hate this formatting. It's just, I don't understand it. I don't like it so much. So I would prefer that they told me f of x minus g of x. And then it's very obvious to me what I should do. I'm going to take my f of x function, which is, and I'm going to subtract my g of x function, which is carefully distributing that minus sign. So I have x minus 1 minus x squared. What happens when I subtract negative 1? Plus 1. Good. And now my negative 1 and the positive 1. And my answer here is x squared plus x. I prefer x minus x squared. Is that right? Everybody okay here? It should be minus x squared. Okay. Now let's find g over f of x. G over f. So now we're going to take g of x and we're going to stick it on the top of our fraction. We're going to take f of x, we're going to stick it on the bottom of the fraction. And right here, we want to state the restrictions. X can't be 1, she says. We're going to get a final answer here, and we're going to know, but at the end of the day, x is not 1. So hang on to that. Can I simplify this x squared minus 1 over x minus 1? Anybody seeing anything in that numerator that pops out at you?
Squared.
Yes?
-1, -1.
No?
X.
It's a difference of squares. Can you see it? It's been a long time since we looked at that. X squared minus 1. That's a difference of 2 squares. How does that factor? Good. X minus 1, x plus 1. All divided by x minus 1. Now we can cancel those. Those are cancel buddies. And so what are we left with? X plus 1. That's our new function, provided that x does not equal 1. What do you think? Don't like it. If you were to graph this function, x squared minus 1 over x minus 1, it actually would look like the line y equals x plus 1, where you start at positive 1, you go up 1, run 1, up 1, run 1. It looks just like this. But when you zoom in at x equals 1, right there, it's undefined, so you would actually see a hole at that point, because we know that x can't be 1 here. We're going to deep dive more into this later. Okay, so you hang tight. This rational function business, this is going to be really solid for you later on. Okay, this is a new thought. This says, this is a new one. Okay, we started with plus, minus, multiply, divide. This is a new one. It's f with a circle. It's not a dot, it's a circle. F and a circle and G looks like fog. And then they follow it with X down here. F of G of X. They're not multiplying. It actually means this. It's a function of the function G of X. This is called a composition of functions. Composition of functions. Oh, we're just about to get fun. Yes. Yes. Yeah, this equals f of g of x. And so the way this breaks down is we have some outer function, and then we have some inner function, g of x. G of x is inner. F of x is outer. You ever eaten a peanut M&M? It's like that. The g of x part is the peanut. The f of x part is the shell. It's the outside part. You ever seen those little Russian dolls that pop out and they're all nested? Russian nesting dolls? You know what I'm talking about? Have you watched Toy Story? You don't know? They pop out and they're like one inside the next one, inside the next one. That's what this is. This is a composition of functions. They are embedded. Okay? So we're going to jump into example 2, and we're going to use these composition of functions. So our first function is f of x equals 2x plus 1, and g of x is equal to 3 minus x. F of x equals 2x plus 1, and g of x equals 3 minus x. And the question here is the composition of functions, commutative? Okay, that's a whole lot of words, commutative. Let me spell it correctly. Hold on. Commutative meaning the same both ways. Is it the same both ways? Okay, I used to commute. I still lived in Pampa, but I drove back and forth to Stinnett every day. I was a commuter. And when I drove to Stinnett, it took me about 35 minutes. And when I drove home, it took me also about 35 minutes. And it didn't matter which way I was going. Commutative means the same both ways. Okay, so the question here is the composition of functions commutative? Do I get the same answer when I do f of g of x as I do if I do g of f of x? If I switch them, do I get the same thing? That's the question. Look alive. Look alive. You're going to either need to stand up or something. Okay, this is going to be hard if we're not paying attention. Okay, so how do I do this? I take my function f of x. Okay, f of x says 2x plus 1. Y'all see that? And everywhere where I run into x, I'm going to open parentheses. See, it says 2x plus 1. So I'm going to say 2, open parentheses, but instead of evaluating this function in terms of x, I'm going to evaluate this function in terms of g. So instead of x, I'm going to pop in here g of x. So open bracket, insert g. You understand? So 2, open parentheses, 3 minus x. And then I go back and finish my f sentence, which was plus 1. See what we're doing? We took 2x plus 1. We subbed out x. We subbed in g. And so we simplify. 2 times 3 is going to be 6. 2 times negative x minus 2x plus 1. What do we get? 7 minus 2x. I like it. That is f of g of x. Now the question is, if we do the other way, g of f of x, do we get the same answer? Okay, so I take my g of x sentence now. What does g of x say, Wyatt? What is my g of x sentence? This top one up here.
3 minus 2x plus 1.
Perfect. 3 minus, and he already input f of x in place of x. 3 minus 2x plus 1. Do you see? I'm swapping out x, swapping in f of x. You following? Okay, so let's simplify. 3 minus 2x. So we took it out. So we talked about this earlier this year. When I substitute, if I send Duncan in on the basketball court for Shub, I got to take Shub out. Right? Otherwise, I got 6 people on the floor. That's not allowed. So if I'm going to substitute in f of x, I'm going to take out x. So instead of x, I'm putting in my f of x sentence. Do you see it? It's not there anymore. 3 minus 2x. 3 minus, or times negative 1, minus 1, however you want to look at that. Negative 2x. You had 2 minus 2x? I like that better. 2 minus 2x. Are those the same? 7 minus 2x and 2 minus 2x? No, so it's not commutative. They are not the same. That's the answer for part 2, example 2. They're not the same. Any questions on that one? Hello, hello? No? No? Marcus, you okay? All right, here's the next one. This is going to be example 5. And we have a table. And we're supposed to use our table to evaluate a composite function. Guys, this is going to be on your homework, so you need to really be paying attention here. It says, using table 1, evaluate f of g of 3. Evaluate f of g of 3. Well, I want to be able to find out what is f of that number. But before I can do that, I've got to find out what is g of 3. So we work from the inside out. Start with your inside function. We're going to use our table. And the first thing I want to know is what is g of 3? What is g of 3? So I go find my x value 3. G of 3 is 2. Can you see it? When x is 3, g of 3 is 2. So now I'm going to use that information to evaluate g of 3, f of g of 3. Well, g of 3 is 2. So now I'm looking for f of 2. What is f of 2? 8. So when x is 2, f of 2 is 8. That's my answer. F of 2, or f of g of 3, is equal to f of 2, which is equal to 8. Okay. Let's do the next one. G of f of 3. So where should I start? F of 3. What is f of 3? F of 3. So I go to x and I find my y value when x is 3. F of 3 is 3. So now I'm looking for g of 3, which is, based on my table, 2. G of 3 is 2. These are puzzles. So g of f of 3 is 2. Okay, I'm going to erase this stuff on this table. I want you to use this exact same table to do this try it down here at the bottom. The try it says find f of g of 1. F of g of 1. I'll blow this table up really big in just a second. F of g of 1, and you're also finding g of f of 4. F of g of 1 and g of f of 4. F of g of 1 and g of f of 4. So on the first one, what are you going to do first? Find g of 1. Find g of 1. So on your table, you're looking where x is 1. What is g? 3. So f of g of 1 actually equals f of 3. Because you evaluated g of 1, you found that that number is 3. So f of 3 now, so I find my x value, and I read my f column. F of 3 is 3. Not so bad?
That's it.
That's it. That's it. If y'all would wake up, this isn't hard. This is a puzzle. It's fun. Look at me like it's fun. Hooray! Okay, next one. G of f of 4. What is f of 4? 1, right? So this is going to equal... Right? Am I crazy?
3.
This is going to be g of 1, and g of 1 is 3. 3 again.
Oh, this makes more sense now.
Oh, good. Imagine what happens when I have your attention.
I had my attention on.
The whole time? All right. Sorry. I thought you were just not paying attention today. Let's do another one. This is a new type. Your homework is also going to have this kind. This is example 7. Using a graph to evaluate a composition function. So they've given me a graph. They've given me actually 2 graphs. The first one is G. The second one is F. They tell you that in the little picture here, but I don't think you can see that. Can you tell? That's G. This one's F. Yeah? Okay. We are looking for F of G of 1. Always start on the inside. So I'm going to read G of 1. That means what is the output? What is the y value when x is 1? So I go to x equals 1. G of 1 is 3. So this is equivalent to saying, what is f of 3? So now I hop over to my f picture. What is y when x is 3, y is 6? Ta-da!
The graph makes it a lot simpler.
You like the graph better than the table?
I like it.
Okay. To each their own. It's the same thing, right? I've got input, output values. You've got to try it here. We're going to use the same picture. Let's see. I've got them written down. Let's find g of f of 2. G of f of 2. So what's f of 2?
So when you say that you just go to the F graph or 2 and see what G equals?
See what y is.
Okay, so 4.5 or is that 5?
I think it's 5. Yeah. When x is 2, y is 5. So f of 2 is 5. So now I'm going to evaluate g of 5. So when x is 5, g is 3. Can we do it? Not so bad? Okay. All right, let's get some functions here. Yes, we love functions. Y'all are enthused today. I'm so proud of you for all of your vigor and attitude. You're welcome. That's Sophia, who has both vigor and attitude. I know. I appreciate you, kid. All right, f of t. We've got t squared minus t. T squared minus t. And we've got h of x, which is 3x plus 2. Well, we already used f for Fred and g for George, and now we're on h for Jorge. F of t equals t squared. There they are. They woke up. T squared minus t and 3x plus 2. And what it wants us to find is find f of h of 1. Find f of h of 1. And again, guys, we want to work from the inside out. So I want to evaluate that inner function first. So what are we going to do? Into 4. So we're going to evaluate h of 1. Plugging in 1 for x into my h sentence. 3 times 1 plus 2 is? So h of 1 is 5. So now I know that f of h of 1 is actually f of 5. Well, now this is easy. I'm just going to plug in 5 for what? T. 5 squared is 25 minus 5. See? So this went from really scary to f of h of 1 equals 20. Start with your inner function first. Okay, so you've seen this 3 ways. Either you've got a table and you've got to read the table inside and then outside. Or you've got 2 graphs, maybe even 3 graphs. You got to read those inside to outside. Or you've got functions, and you're going to plug into your inside function and then plug that into your outside function. Any questions here, guys? You want to try it? Yes? You got 3 minutes. That's good enough time for a try it. Here you go. I'm going to give you both of them. Here's your try it. And I think you have like 7 minutes. You have plenty of time for a try it. F of t equals t squared minus t, so same functions here. H of x equals 3x plus 2. Your job is to find part A, h of f of 2. And part B, h of f of negative 2. Don't forget parentheses. You can do it, you can do it, you can do it. It's like Cinderella, I think. All right, talk to me, Shub. What'd you do for part A? What's the first thing you did?
Plugged in 2 for the t squared minus t.
Okay, so he plugged in 2 into his f function. 2 squared minus 2 left you how much?
2.
2. So now you're going to evaluate h at 2 because f of 2 equals 2. So what is h of 2? We got 8. Perfect. 6 plus 2. How about the second one? Katie, what'd you do? Okay.
But you would plug it instead of f,
Plug in into f, negative 2. Good.
so negative 2 squared
With parentheses,
plus 2.
minus negative 2, so plus 2. Good. And what is negative 2 squared with beautiful parentheses? 4. Good. 4 plus 2 is... So f of negative 2, that inner part, is equal to 6. So we're going to now evaluate h at 6, and we get 20. Cool? Okay, what looked super daunting is not that bad. You got to be awake enough to know what's going on, but it's not bad. Okay, you've got homework tonight. I tried really hard to format it where it's easy for you to see what to do. Good luck. Come see me if you have questions in the morning.